Alright, what is up guys? It's Joe here. I make tech videos on YouTube, and today's problem is kth smallest element in binary search tree. So you can see here I have two binary search trees where we have k equal to 1 as the first value and k is equal to 3 in the second value. And essentially here, just as the problem says, we want to find the kth smallest element. So in this case we want to find the smallest element, which is the first smallest element in this tree. If we look at this tree and we just take the sorted order of this tree, we can see that the first smallest element in the tree is going to be 1, so that's going to be our answer. And if we do the same thing for our k equals to 3 tree here, if we just write out the sorted order of this tree, we can see that the kth smallest for this, or k is equal to 3, is this value 3 here. So you can see that there's one approach here where we just take the sorted order of the tree itself by using an in-order traversal, which will give us this array here, and just go and make a O of k scan to find the kth value. So that would end up being O of n plus O of k time for that linear scan, which in the end would be O of n time n space to fully complete the problem. But another way we can do this is that instead of generating this sorted array here, we can just keep track of which spot we're at while we're traversing the binary search tree, and say we are at k equals 3 here. We'll start here and we'll be traversing down to here. Once we finish with this node, we'll minus 1 from k, we'll get 2. Then we will come back to 2 here, minus 1, because we'll finish up with this value 2 at this node, and then we come back to 3, and this will be 1, and once we finish up with this value, we'll be at 0, and we'll return back this 3 as our answer. Alright guys, so here we go to the implementation. So we'll have our initial method here, and we'll just check first to see if the root is null. If the root is null, we'll just return back -1. Otherwise, we'll have here some global variables. That will be a k value, which will be the initial value of our k, and the answer, which will contain the answer for this method. And so here we'll set up our k to be whatever k is here. We'll perform a depth first search on the root, and then we'll just return back whatever our answer is. And here we'll have a private method, and it'll be called DFS. We'll take the tree node root, and here we'll just check if the root is equal to null. We will just return. Otherwise, we'll go ahead and depth first search on the root.left. Then here we'll say k.value or k value minus minus. And then here we'll say that if the answer is equal to -1, meaning that we haven't modified it and found our actual answer, then we can just return, or actually if the answer is not -1, meaning we have found our answer, then we should just return, so that way we don't have to recurse through the entire tree. And then here we'll say that if the k value is equal to 0, then that means that we are at the kth spot, kth smallest element in the binary search tree. So we'll say that the answer is root.value, and then just return, so that way we don't have to go through the whole tree. Otherwise, we'll go ahead and go to the right side. And that'll be it. Let's see. And that's it, guys. So please comment, like, subscribe, and let me know if you want more stuff just like this.